Hello everyone. In this video, we'll be solving problem related to decay of charge. Okay, so I'm giving you a problem. These are two resistors. Okay, having value R and R. They are connected here. More resistor. Okay, this is connected. Now you need to find charge on capacitor as function of time, and this is given as T and this is given as T. And also the charge at T equal to tau by Tc by 2. You can say tau C by 2. Okay. So pause the video and try to do it yourself. Okay. Okay. See, in steady state, actually this is not a problem of you can say only a decay of charge. Okay, this is a problem of growth of charge as well. Okay. Now, in steady state, this capacitor will be behaving as open circuit. Why so? Because this capacitor is charged. Okay. In steady means in steady state means long after switching on the key, or you can say long after opening the closing the circuit. Okay. So the current which will be flowing through it will be passing through it, and will bypass the circuit. Okay, means there will not be any current flow to the circuit. Okay, in steady state, we are talking about in steady state. Okay, so I will be E upon R plus R is E upon 2R, right? And the potential difference across this circuit will be VA minus VB. If you consider this point as A and this point as B, it will be VA minus, write it, VA minus VB equals to, this is a point A and this is point B, I into R. And what we have found at R, what we have found at I, E upon 2R. And what is the value of R? It is this resistance R, right? That means it will be E upon 2. Okay, now you know that tau C is time constant. It is actually C equivalent into R equivalent. Okay, now for R equivalent, C equivalent is this. Okay, for R equivalent, it will be, see, these two are connected in parallel and the third one is series. Okay, for modified circuit will be something like this. We are talking about steady state situation. See, we know that C equivalent is this. Okay, and for finding R equivalent, I'm telling you one thing, that while finding R equivalent between A and B, okay, replace the battery by its internal resistance if any internal resistance is given. Okay, if internal resistance of battery is 0, then the battery is replaced by a conducting wire. So we are replacing this battery, we are doing all these things just to find R equivalent. Okay, so we are replacing the battery E by a conducting wire. Why? Because there is no internal resistance of the battery. Okay, so the circuit will be something like this. A, this is B. We need to find, actually this is A, this is B, but we need to find the R equivalent between these 2 points. Okay, it will be what? See, this resistance and this resistance, these two are in parallel, and this parallel will combine with this resistance R in series. So R equivalent will be R by 2 plus R. That means 3R by 2. So tau C will be, C equivalent is actually C into R equivalent is 3 by 2 r. So 3 by 2 cr will be your time constant. Okay, now during charging of capacitor it is q naught 1 minus e to the power minus t upon cr, right? So q as a function of time, it will be ce by 2 1 minus e to the power minus t upon your this is actually cr means c equivalent into r equivalent. This thing. Okay, it will be 3 2 will come here 3 by 2 cr. Actually, if it's written wrongly, you can write this r as something, right? qt will be this. Why c e by 2? Because the potential difference across this was e by 2. Okay, the charge will be c into e by maximum charge. Now at t equal to tau c by 2, just put the value of t equal to tau c by 2 here. You will get q as a function of t equal to ce by 2 1 minus e to the power minus t. You can write tau c by 2, and here it is tau c. This 2 will cancel out. You will get t equal to ce by 2 1 minus, I think it will be e power 1 by root, so it will be 1 by under root e. This will be your charge at t equal to tau c by 2. Okay, so now practice more problems on growth and decay of charge, and from our next video we will be analyzing when a capacitor is charged and charging batteries remain connected. Okay, then we'll be taking the second case when capacitor is charged and charging battery is removed. Means what will be the effect of inserting dielectric on capacitor, potential difference, and all this. Okay, and then we'll be doing problem on symmetric circuit. After that, the force on dielectric means the fringing electric field, and our capacitor will be over. Thank you.